Hi there, this is Imran here. In this video you would learn about return on investment techniques such as net present value, internal rate of return, profitability index and payback period. These are also called as capital budgeting techniques. The knowledge that you would acquire by learning capital budgeting techniques would be helpful for you in project management, program management, financial management, and for students who are attending MBA classes. If you're preparing for PMP or Prince2, it is very important for you to learn the capital budgeting techniques because you may get a couple of questions in exams that you may need to answer with respect to decisions you make to choose between different projects. And if you're a project manager and if you're not aware of capital budgeting techniques, then I would say you must learn the capital budgeting techniques. And the reason being, it would help you to make informed decisions when you're faced with challenges with respect to financial viability and business justification of the projects. Capital budgeting techniques fall under the branch of financial management. Let me give you a brief overview of where does the capital budgeting technique fit into under financial management. Financial management is primarily divided into two functions. 1. Corporate finance. 2. Accounting and control. These are further divided into sub-functions. Each function is a big subject in itself and would take hours, if not days, to learn about each function. And our focus would be on capital budgeting techniques function. The reason why I'm showing you the financial management overview is that it would help you to understand where exactly the capital budgeting technique fits into under financial management. And if an organization decides to undertake a project, it would usually do two studies. One is technical feasibility and other is financial viability. If the project is not technically feasible, then there is no point in going ahead with the project. And if the project is technically feasible, then the organizations would conduct financial viability for the projects with the help of capital budgeting techniques. Okay, so the point is, what exactly is capital budgeting technique? Capital budgeting technique is a planning process. It determines whether it is worth to take or invest organization's capital into projects, and it always works for the benefit of the firm by increasing its financial value. And before we get started to learn about capital budgeting techniques, it is very important for you to learn about the terms discounted cash flow and non-discounted cash flow. So the question is, what is discounted cash flow? And to explain this, we must first understand that time has a money value. Discounted cash flow takes the time value of money into consideration. For example, the money in hand today, if invested in a bank, will earn, let's say, 6% per annum. So this 6% can be considered as a discounted cash flow. And you need to remember one thing. It's not only about the interest rate. It could also be the rate of return that an organization gets back if it invests the money in a business, which could earn more than the interest rate. And let's say 8% rate of return is what we are getting by investing the capital in a business. Then this 8% rate of return should be considered as a discounted cash flow. And this discounted cash flow is also called as opportunity cost of capital, or sometimes it is just referred as cost of capital. And now let's move on to non-discounted cash flow. Now this is simple. It does not take time value of money into consideration. So therefore the interest or the rate of return is not taken into consideration. Now let's see what is opportunity cost of capital. What is opportunity cost of capital? Opportunity cost of capital is something that you would give up in order to get something else. Now, let me ask you this question. Now, what do you think is the opportunity cost for me for making this video? If I'm not making this video for you, then I would be spending this time going out with my friends, or I would be spending time with my 1.5-year kids. So the opportunity cost of making this video is the time lost spending with my kid or with my friends. And it applies to everyone, even you watching this video. If you're not watching this video, then you would be doing something else. And the opportunity cost for you would be that something else. And then the big question comes, why do people let go of the opportunity cost? The reason is because people think rationally, meaning you weigh the pros and cons of all mutually exclusive alternatives available. You would choose the best alternative available at that point in time, because people expect to achieve greater benefits choosing one alternative over the other mutually exclusive alternative. Discounted cash flow is nothing but the opportunity cost of capital. So when I say discounted cash flow, it also means that I'm referring to the opportunity cost of capital, or just say cost of capital. Now let's look at these capital budgeting methods. Net present value, internal rate of return, profitability index. Now these capital budgeting techniques would always consider the discounted cash flow. Without taking into consideration the opportunity cost of capital or the discounted cash flow, we cannot calculate the net present value or internal rate of return or profitability index. However, for payback period, the opportunity cost of capital is an optional. Mostly when calculating payback period, the discounted cash flow is not considered. Now let's look at the future value, present value, and let's understand the relationship between future value of money and present value of money. For example, let's say you have $100 in hand today. Then what would be the future value of that $100 after 1 year? Similarly, if you're going to get $100 after 1 year for sure, then what is the present value of that $100? Now we should be able to calculate the future value or the present value if one of the two information is available to us. Now we can calculate using the formula FV is equal to PV multiplied by 1 plus K whole power n. K in this formula is the discount rate. In other words, it is also the opportunity cost, and n is the number of years. Now let's look at calculating the future value and present value with some examples. Let's first look at calculating the future value. If you have $100 and if you invest that money in a bank today, and bank promised you to give you 8% per annum interest, what would be the future value of that $100 after first year, 5th year and 15th year? Now here $100 is the present value of the capital, and 8% is the opportunity cost of capital. Now 8% means 8 by 100, that is equal to 0.08, and 1 plus K here is 1 plus 0.08, that is 1.08. Now you can see this on the screen here, 1 plus K value, K value and present value. Now let's use the formula and calculate the future value amounts. Now that we know the present value, 1 plus K value and the n value, it's easy to calculate the future value. Future value after 1 year is $100 multiplied by 1.08 to the power of 1, and that gives you $108. And future value after 5 years is $100 multiplied by 1.08 to the power of 5, and if you do the calculations, it would give you $146. And similarly, we can calculate the future value of $100 for any period of time using the formula. It could be for 15 years or any number of years, and for 15 years we are getting the value as $317. Now I would request you, after you watch this video, come back to the video again, pause the video on the screen, take a pen and paper in hand and do the calculations. Now this would help you to get prepared for the examinations, and do this for all the examples in this video that I show for calculations. Now let's look at how to calculate the present value. Let's say you have three scenarios where you're going to get $100 after 1 year, 5 years and 15 years. Then what would be the value of $100 today? Now we have the formula through which we can calculate the future value. We would use the same formula to calculate the present value. The formula is present value is equal to future value divided by 1 plus k to the power of n. Here the future value is $100 and the opportunity cost of capital is given as 8%. I'm sorry. Now using the formula we can calculate the present value. The present value of $100 to be received after 1 year would be 100 divided by 1.08 and that would give you $93. And similarly we can calculate the present value of $100 to be received after 5 years or 15 years, and for that matter any period of time as long as we know the future value and the discount rates. Now on the screen I have just done the calculations for the present value for 1 year, present value for 5 years, present value for 15 years. Now you can just pause the screen and you can do the calculations, or you can come back and do the calculations. Now that we have learned how to calculate the present value and future value, it is just a cakewalk for you to calculate the net present value. And before we learn how to calculate the net present value, let's look at the few important points that we need to keep in mind and remember in order to calculate the net present value. Net present value is determined by subtracting present value of all cash outflows from the present value of all cash inflows. Meaning you would need to take into consideration all the cash inflows for a project and calculate their present value, and we need to sum up all the present values, and from the sum of all present values you would need to subtract the cash outflows, and that would give you the net present value. I know you're confused a little bit here, but do not worry, this would become clear when you look at an example in the next coming slides. And this is very important to remember. Once we calculate the net present value, it should always be positive for the project to be accepted. If the net present value is negative, that means the project is not financially viable. Now let's get into the nitty-gritty of calculating the net present value. Here is an example. A sum of $400,000 is invested in an IT project, and below we have the cash inflows for the project up to a period of 5 years, and the opportunity cost of capital is given as 8%. All we need to do is calculate the net present value, and basis the net present value decide if the project is worth undertaking or do we need to reject the project. See, in this example the $400,000 is spent outright initially, so it is called a cash outflow. And coming to the revenue from the project, at the end of first year the project generates $70,000, and at the end of second year the project generates $120,000, and at the end of third year it generates $140,000, and for fourth year it generates $140,000, and at the end of fifth year it generates $40,000. Now that we know how to calculate the present value, we need to calculate the present value for year 1, that is for $70,000, and for year 2, that is $120,000, and for year 3, $140,000, and year 4, again $140,000, and for year 5, $40,000. Now once we get the present value for the year 1, 2, 3, 4, 5, we need to sum them up and subtract the $400,000, and that gives us the net present value information. And if the net present value is positive, we should accept the project, and if it is negative, we should reject the project. Now, I have done the calculations here. I got all the present value details for all the years, and when I sum them up, I got the total value of all cash inflows as $408,000 $959. And for us to calculate the net present value, we have to subtract the cash outflows from the cash inflows. Remember, the cash outflows for this example was $400,000 that was spent initially. So that becomes cash outflow. Now that we have the cash inflow for all the cash inflow of all present values, which is $408,959, we need to subtract $400,000 from this amount, and that would give us $8,959. And since this net present value is positive, this project can be accepted. Okay, now let's look at another example. The same example, I would say, what we've done is we've just changed the opportunity cost of the capital from 8% to 15%. Now this was 8% in the previous example, and this is 15% in this example. And let's see if the project is still financially viable. Amount remains the same, the time period remains the same, it's only just the opportunity cost that has changed from 8% per annum to 15% per annum. Now let's look if this project is still financially viable or not. I've done the calculations on the screen. We know the formula for present value. Now using the present value formula, we would calculate the present value for year 1, year 2, year 3, year 4 and year 5. That gives us these values here on the screen. Now if I sum them up, I get $343,591, and the cash outflow which we have done initially is $400,000. Now if I subtract $400,000 from $343,591, I get the net present value as minus $56,408. Now the net present value has become negative here, so we should not accept this project because this project is not financially viable. Now look at the note on this page below. Though we have the same inflow and outflow of cash when compared to the previous example, the net present value has changed from positive to negative when the opportunity cost of capital has increased from 8% to 15%. Now what does this say? They say that net present value is very much dependent on the discount rate or the opportunity cost of capital. Now with this example we complete the net present value, and now let's move on to the internal rate of return calculations. Now generally speaking, the higher the project's internal rate of return, the better, and it's more desirable to undertake the project. Internal rate of return is the calculations by which we would be able to tell how much rate of return are we getting from the project. So higher the internal rate of return, the better for the project. IRR, which is also called as internal rate of return, can also be used to rank projects. Now IRR is nothing but the discount rate at which the net present value becomes 0. Now I'll make it clear in a moment. Now, let's say you have to choose between two projects where the net present value of two projects is same, and you're asked to choose one of the projects. Then you would need to choose the project which has the higher internal rate of return. Now you may get a couple of questions in exams asking you to choose between two different projects. They may give you the net present value details, internal rate of return details, and they would ask you to choose one project among the two projects. Then you would need to choose the project which has highest internal rate of return. And remember this point, the project's internal rate of return should be greater than the opportunity cost. If the project's internal rate of return is greater than opportunity cost, you should always accept the project. And if the project's internal rate of return is less than the opportunity cost, you should reject the project. Because if the internal rate of return is less than the opportunity cost, the project is not financially viable, and it is better to invest the money in a different project where we have a better internal rate of return. Now let's look at the relationship between internal rate of return, opportunity cost, and the net present value. If IRR is greater than the opportunity cost, then the net present value will always be positive. And if IRR is less than opportunity cost, then the net present value will always be negative. As said earlier, as long as the net present value is positive, the project is financially viable. And the moment the net present value goes to negative, the project is not financially viable. Alright, now let's see an example and calculate the internal rate of return for a project. The project, let's say the project cost is $1,000 and the time span is 5 years. And it generates $200 at the end of year 1, $300 at the end of year 2, $300 at the end of year 3, $400 at the end of year 4, and $500 at the end of year 5. The opportunity cost is given here as 12%. And now we are asked to calculate if the project is financially viable or not basis the internal rate of return. Now let's look at the solution. First we need to calculate the net present value of the project. Then adjust the opportunity cost until we get the net present value to 0. The opportunity cost at which the net present value becomes 0 would be the internal rate of return. So we will tackle this solution with the following in mind. If the NPV is positive, that means at 12% opportunity cost, the net present value is positive. So we need to increase the opportunity cost above 12% and see where does the net present value become 0. Once we find out the rate at which the net present value becomes 0, we need to consider that rate as internal rate of return. Now I would show you how the calculations are done. Let's see the Excel sheet which is attached in this pitch, and you would get a fair idea as to how the internal rate of return is calculated. Now we know the formula to calculate the present value, and using the formula I have just automated this in the Excel report, and let me show you how it is done. Now we have all the future values here for year 1, year 2, year 3, year 4, year 5. We know what the discounted rate is. It's 12%. That's given in the example here. I have calculated the present value for year 1, year 2, year 3, year 4 and year 5. Now I got cash inflow for all present values as $1,169. I know the cash outflow is $1,000. So I calculated the net present value, which is $169. Now for us to calculate the internal rate of return, what we are doing is we need to adjust the discount rate. As I said, the internal rate of return is nothing but the discount rate at which the net present value becomes 0. Now at 12%, the net present value is $169. So let's increase the 12% to 13% and let's see what would be the net present value. So it dropped to $136. Let's look at 14%. So it went to $105. Let's see 15%. It's $75. So net present value is dropping as we increase the discount rate. Now let's look at 17% interest. Sorry, 17% discount rate. It's $18. Let's see 18% discount rate. So it went to negative. So it should be in between 17 and 18. So let's look at 17.5. Right, it's 5.5. So let's see 17.6. It's 2.8. 17.7. Now it is close to 0. 0.24. If I make it 17.8, it went to negative. So at 17.7% discount rate, the net present value becomes 0. Now this would be the internal rate of return, because at 17% discount rate, the net present value have become 0. So this would be considered as the internal rate of return. Now let's move on and let's look at the profitability index. Before we move on to profitability index, let's just look at this. 12% discount rate, the net present value is $169, and at 17.7% it has become 0.24, close to 0. So the IRR is 17.7% for this project, which is a pretty good internal rate of return. Let's get on to profitability index. What is profitability index? It is also again a decision-making criteria to choose projects. Now it is a ratio by which we can tell how many dollars can be earned in return for each dollar spent. For you to be able to calculate the profitability index, you should know the present value of all cash inflows and cash outflows, and then divide the cash inflows with cash outflows. And you should be able to get the profitability index. I'll show you how to calculate the profitability index in an example. Now, you need to remember this. You should accept the project if the profitability index is greater than 1. And you should reject if it is less than 1. Again, the higher the profitability index for a project, it is more desirable to undertake the project. And let's look at the relationship between net present value and profitability index. If net present value is greater than 0, then the profitability index is greater than 1. If the net present value is less than 0, then the profitability index is less than 1. And remember this point, this is very important. Profitability index can never be negative. It would always be greater than 0. The reason being, you're not subtracting the cash outflows from cash inflows. We're just dividing the cash inflows by cash outflows. So therefore, the profitability index can never be negative. It would always be greater than 0, and the ideal profitability index should always be greater than 1. And anything less than 1 for profitability index, the project is not financially viable. Now let's look at the example for profitability index. Now in this example, an investment of $25,000 is invested in a project which is giving you a series of cash inflows. That's here. It's giving you $5,000 at the end of year 1, $9,000 at end of year 2, $10,000 at end of year 3, again $10,000 at end of year 4, and $3,000 at the end of year 5. And if the required rate of return is 12%, what is the profitability index? Now, profitability index is calculated by dividing the present value of all cash inflows by present value of all cash outflows. So first we need to calculate the present value of all the years here, and sum them up and divide it with the cash outflow. Let's see the Excel sheet in which I have automated using the formula to calculate a profitability index. Alright, we know the formula for present value. Now we know all the future values. We know the years are 1, 2, 3, 4, 5. I know the discount rate is 12%. I have automated the formula here to calculate the present value for year 1, calculate the present value for year 2, present value for year 3, for year 4, and for year 5. Now I got the individual present values for year 1, 2, 3, 4, 5. Now if I sum them up, I get $26,814. Now in this example, the cash inflow for all the present values is $26,814. But we have been given $25,000 as cash outflows. Now all we need to do is divide $26,814 with $25,000, and that would give you the profitability index. Here is the profitability index, 1.07. So the profitability index for this project is 1.07. As I said earlier, if the profitability index is greater than 1, we can accept the project. Now if we change the profitability index, the discount rate, it would affect the profitability index. So if I increase this, it becomes 1.04. See, as I increase the opportunity cost, the profitability index went down. So we have a direct relationship between the discount rate and the profitability index. Okay, that's about the profitability index. Now let's move on to the payback period. Now, what is payback period? It is the length of time required for an investment to recover its initial cash outflows. For example, if you invest $1,000 in a project and it generates $500 every year for a period of 5 years, then what is the payback period? I would say the payback period would be 2 years, because it takes 2 years to recover the $1,000 we invested in the project initially. So the payback period is 2 years. And generally speaking, organizations do not consider time value of money in payback period. And again, it depends on the organizations you're working for. However, if you want to take the time value of money into consideration for calculating payback period, you may do so. And here is the important point. Good projects will not only have a good internal rate of return or the net present value, but they also have early payback periods. So if you're given a couple of projects with good internal rate of return and net present value, choose the project which has early payback period. If the internal rate of return and net present values are the same for the projects, you should go with the project that has the early payback period. Now let's look at the example that's on the screen, and I think with that this video would come to an end. In this example, an investment of $25,000 in IT projects give a series of cash inflows as described below. At the end of first year, $5,000. At the end of second year, $9,000. At the end of third and fourth years, $10,000. And at the end of fifth year, it gives you $3,000. So what would be the payback period for this project? The solution is simple. We need to calculate the time it takes to earn $25,000. Since we are not given the discount rate, we need to just calculate the payback period without considering the opportunity cost. So at the end of first year, we got $5,000. And at the end of second year, we got $9,000. So the total amount we got at the end of second year is $14,000. It's just the cumulative of all the revenue that we get at the end of the years. Okay, so at the end of third year, it becomes $24,000. Since we need to get back to $25,000, let's see, if I calculate this, the cumulative of 4 years, it would become $34,000. Since we are concentrating only on $25,000, let's break the fourth year revenue into month-wise revenue. And that would be 10,000 divided by 12, and that is $833 per month. So for 3 years, 1 month, we would earn about $24,000 plus $833, and that would be $24,833, close to $25,000. And in 3 years, 2 months time, we would earn about $25,666. So we can say that the payback period is in between 3 years, 1 month and 3 years, 2 months for this project. Okay, so that's about the payback period. Payback period is easy to calculate. All we just need to do is just calculate the amount at what period of time we would be able to recover the initial investments. Alright, so let's have a quick recap. In this video, we learned about the capital budgeting techniques. We learned what is discounted cash flow and non-discounted cash flow. We learned how to calculate future value, present value. We learned how to calculate the net present value, internal rate of return, payback period, and profitability index. And with this, we end this video tutorial. If you find this tutorial informative, please subscribe and comment.